that should be enough information to decipher whether you have a fault, how to test the fault, or how to test the components, see if it's working properly. So I hope this has helped.
My name is Alan Hart, and today we've got the friendly Ideal engineer back, and he's going to go through an F1 fault or a low pressure fault on a boiler, on an Ideal Logic or an Ideal Vogue, and he's going to go through testing the components. So he's not going to go through showing you how to top it up. We've done plenty of videos for that, but he's going to show you how to test the component that reads the pressure. So yeah, without further ado, let's go over to our Mr. Ideal.
Hello YouTube. I'm back with another video. This time we're going to talk about low water pressure. On our boilers it's generally F1, or it will display the words low water pressure. I'm not going to talk about how you top it up, or you know, look for leaks, recharge the expansion vessel. I think most people generally know about that. What I'm going to talk about is the components within the boiler that measure low water pressure, how they work, how you test them, that kind of thing, and hopefully you'll get some use out of it and some knowledge. So the two main components that we use or have used in our boilers is on our older 2009 to probably 2015 models, we used this, which is a water pressure transducer, and on our current models we use this, which is a low water pressure switch. First off, this one, the transducer, it's basically an electronic device which converts energy from one form to another. So in our case, we're converting water pressure into an electrical signal. Some people call this a pressure sensor, but it's technically not a sensor, because a sensor will only give an output in the same format. A transducer will actually convert the measurement into an electrical signal. Basically, how it works, it uses a flexible diaphragm inside which deforms when the pressure, when it's pressurized, and a transduction element transforms the deformation into an electrical signal. In our case, we have a 5-volt DC supply to the transducer, and when the pressure within the heating system measures 1 bar of pressure, it'll send 1-volt DC signal to the circuit board. So if you have 2 bar of pressure in the boiler, you'll get 2 volts DC. So the boiler knows how much pressure is within the heated circuit. This switch, it works slightly differently. It's a very simple concept. It literally, the contacts are open and closed depending on the pressure within the heating system. So for instance, when the pressure increases, the contacts close to create the circuit, and when the pressure decreases, the contacts open and the circuit is broken. However, on some older boilers, I think this actually works in reverse. So, you know, you best, if you're working on an older boiler, you just make sure that, the open and closing can work in the opposite fashion. Inside, it's just a little diaphragm and a spring mechanism, which when the pressure increases, it forces the piston onto the micro switch, so the contacts, changes increased, and then so it increases and decreases in pressure, the contact changes. So, it opens and closes with pressure. Some older boilers, again, they used 3 contacts, and they had common, normally closed and normally open. I think depending on the way that the pressure was read, again, they could work in reverse. So I'd check with the manufacturers, if you're on an older type boiler with 3 contacts, give the manufacturers a ring and just check which way around it works. But in our principle, it's just a switch, an open and close switch, which makes it really simple. It works on the premise of half a bar of pressure within the system will move the diaphragm and push the push rod onto the micro switch, creating the circuit, and below half a bar it will break the circuit, so it will be open. An open circuit will read either open loop, open line, whatever you want to call it, or mega ohms, and a closed circuit will read 1 ohm. So I've done a bit of a diagram, as you come to expect now. So we'll look at the transducer first. This is the picture of the water transducer. We've got 3 cables. They're on the low voltage side of the circuit board, so you'll have to trace the cables. You can tell the difference between high voltage and low voltage side of the circuit board, generally because the high voltage side will have larger connections and larger diameter cable harness. On the low voltage side you'll see smaller connections and the thinner harness cables. So as you can see, we've got an orange, a black and a red. The orange is the signal back to the PCB, the black is the ground or the neutral, and the red is the supply from the PCB. So what I've done here, I've noted between the red and the black you'll get a permanent 5 volts DC from the circuit board at all times. So if you're testing between red and black, expect 5 volts DC on your multimeter. That should always be there. If the power's on, fusing the PCB is okay and the PCB is working, you'll get 5 volts. Again, testing between orange and black, you'll get 1 volt DC at 1 bar of water pressure in the boiler, or in the system should I say. So you've got 1 bar in your heating system, you should get 1 volt DC signal back if this transducer is working. If the transducers fail, you'll probably just get 5 volts back on the orange and black, or 5-6 volts or something back. You'll probably, I've never really had one fail, but they can get blocked, or they can, you can just completely go, and you'll just probably get 5 volts back. And the boiler will probably still read low water pressure. If you've got a fault with the transducer, it'll probably still read low water pressure F1, even if it's sending 5 volts back. It just can't read it. So that's that. On the switch side, it's a bit different. It's quite straightforward. We've got, I've put orange and black on here, but it's got 2 wires, quite straightforward. As you can see, below half a bar, the circuit opens. So if you've got less than half a bar in the system, between orange and black, you'll probably read mega ohms, or open line, open loop, some people call it. If you've got greater than half a bar in the system, the circuit will close, creating the circuit, and you'll get a reading of less than 1 ohm. That's how we measure it. What I'll do, I'll set up my multimeter and we'll do some actual measurements to show you how it exactly works. Okay, as you can see here, I've got my multimeter set it to ohms. I've found the pressure switch, which is this here. You can see the black and orange cable. I've accessed the circuit board. I've found the low voltage side of the circuit board. As again, you can see the connections are smaller to the mains voltage, and the mains voltage cables are thicker. The low voltage cables are thinner. I've found the orange and black here. I've connected my multimeter up to it, and because before, when you saw the front of the boiler, it had 0 bar of pressure in it, and it came up with an F1 fault code. Now we're reading OL. There's literally no water in the boiler, so the circuit is open. What I'm going to do, I'm going to try to do this with one hand. I'm going to put some pressure in the boiler, and there you go. You may have heard the click as well. You saw my multimeter change to 1.3 ohms. It's saying 1.3 because my leads test about half an ohm. When you test them together, you'll get a bit of resistance through there. So if you take off the 0.5, you'll get like 0.8. So that's less than 1 ohm, which we said we'll get there. Greater than half a bar, you get between 0 and 1 ohm, and that's what we're reading there. I just topped up the pressure. You heard the click. That's how you test that switch. It's as simple as that. I'm going to show you another video now, and I'm going to talk over it. It was a video that I did a while ago, and it's how to test the transducer. So again, first what you would do, you would trace the cable from the transducer, trace it back to the circuit board on the low voltage side. Find your orange, red and black. Make sure it's connected to the transducer and connected to the circuit board. Set your when you're testing a transducer, you can't really do a dead test, if you will. I've seen somebody do that before on YouTube, and it really doesn't make any sense. You tested the resistance for it, and it really doesn't tell you anything, to be fair. You've got to do it live, so you know, make sure you've done all your electrical checks, you're working safely, you know what you're doing. Make sure you're working safe at all times. First test we do, we find the red and black cable on the circuit board, and we make sure that we're getting the 5 volts DC from the PCB. That's the first thing we have to do. If we're not getting that, then nothing else is going to work. So we test for 5 volts DC. We are getting 5 volts DC from the circuit board. So then our next test is to trace the orange and black cable, and again we expect to see 1 volt DC at 1 bar of water pressure. If you're not getting, if your pressure gauge is reading one reading and your transducer is reading another reading, it may be that your transducer is okay, but the pressure gauge may be blocked or faulty. So you'll have to determine which one is at fault. I can't really tell you how to do that, to be honest with you. That's something you must decide yourself. But we are getting the right voltage. So what I'm going to show you now, I'm going to show you how what happens when you drain the boiler. I'm going to drain the boiler and then have my multimeter connected, and as I'm draining it, you'll see the signal from the transducer to the circuit board changing. You'll see the voltage dropping, and that's just to show you how it works. So that's what I'm doing now. I've got it drained into a bucket. The boiler's draining down slowly, and if you can see the multimeter, you can see the voltage dropping on the multimeter, and that's just showing you that the transducer's working properly. Like I said, you can get blocked. I mean, the water ports on these components are quite large, but you know, system debris are large as well. You can get chunks of iron oxide stuck inside these, which it won't register with the PCB board, so you can get you can be blocked. They can go faulty. It's very rare they do, but they do. Also, your wiring harness, you can have a fault with the wiring harness, so you need to be checking continuity, and that's why it's best to test it from the circuit board rather than the component itself, because when you're testing it from the circuit board, you're also testing the wiring harness for continuity, so you're doing 2 tests in one. That should be enough information to you know, decipher whether you have a fault. how to test the fault or how to test the component to see if it's working properly. So I hope this has helped, and I'll try and do some more when I can.
Thank you very much for that, Mr. Ideal. I hope this video has been of some use to you. Please, if you can, always read the installation instructions. I put these videos together, so Mr. Ideal sends me the little clips and I put them all together. So sometimes we might get some of the clips the wrong way around, some of the wires, etc. So always check the wiring diagrams with the boiler you're going to be working on, and always make sure you're working safe. And as always, these videos are designed for trainees that are under supervision or fully qualified gas engineers, just to give you a little bit of an idea on how to test components and just hopefully just further your knowledge a little bit. But if you can help, if you've got any comments, please put them below, and hopefully then other people can watch them, read them comments as well, and hopefully it'll help them. Yeah. Once again, thank you to Mr. Ideal, and thank you to everybody who's watching.